Hello, welcome back to the Oxford Online Maths Club. My name's James, and today I'm joined by Beth.
Hi.
It's Beth. Beth's been on the show before. Um, uh, Beth's back to talk to us about maths. Generally, I don't have a good title for this episode. I think it's currently just puzzles! Exclamation mark, and I might fill in something more descriptive once we've seen the puzzles. But no spoilers early on. Beth, do you want to introduce yourself? Just say what's
Sure.
new.
I've been on the live stream before.
You have.
Talked about spheres. If you haven't seen my episodes, please go back and watch them. They're quality. Um, I'm Beth. I study maths. I'm a third year. I'm at New College, Oxford. And yeah, that's me.
How's your day going, Beth, on a scale from 1 star to 5 stars?
It's been pretty good because all my deadlines are in. I'd say about 4.5.
Pretty good. That's a pretty high score. Let's see how
Yeah.
chat's doing. Chat's immediately voted for 1 star and 5 stars. Those are different people. One of them having a much better day than the other. Uh, Mary and Rex say hi in chat, and also hi to Beth, who
Oh,
I
hi.
think they've met before. Heebie Jeebies says, "Yay, puzzles!" Which is, I think, the right attitude. We'll let them vote. We'll let them do the how's your day vote. The theme for this, if it's a theme, I don't know. We've done previously. We had an episode a couple of years ago that was called something like Winter Puzzles,
Mhm.
because Jane Street had sent me a puzzle. It was like a physical thing, in the shape of a snowflake for Christmas.
That's
Uh,
cute.
and we'd previously had summer puzzles, which was just a sort of before the summer holidays. Here are some puzzles to think about. So I guess maybe this is spring puzzles.
Ring puzzles.
Spring puzzles. That's the concept. Right, now play along because I've already decided what the puzzles are, so we will have to work out why they're spring puzzles as we go along.
Got this.
Winter puzzle had a snowflake. Summer puzzle, I don't know if I tried. Spring puzzles, we can make it work.
We can make some links.
Quick adverts at the start. All the adverts on the screen are for more Oxford stuff, right? We have a mailing list where you can find out about more things. We have further reading notes. I published 2 further reading notes over the weekend, catching us back up with where we're supposed to be. Um, Chat's being distracted by chat because they're having a really medium day. 3 never wins this poll. 3 stars is never like the modal option, and it's maybe about to win, which is like, I don't even know what to say with people who vote 3 stars on the poll. Like normal. It's in the middle. No, somebody else just voted 1 star. Right, good. Right, okay. Before that gets out of hand, I'm gonna leave that. Oh, and I've got to mention Jane Street. I put their logo on here. There we go. That's the Jane Street logo. Jane Street are sponsoring the live stream, or they've donated generously. Thank you, Jane Street, to help us run the live stream. They're really interested in puzzles. They're a trading company. You can find out more about them by clicking the link at the bottom of the Maths Club homepage. But they're also really keen on puzzles. It seems like the sort of place where everyone who works there is keen on solving puzzles as well. They've got photos on their website of people who work there just sort of messing around solving puzzles. Maybe that's good for you if you work at Jane Street to also solve some puzzles. Anyway, they sent me some puzzles. I have adapted their puzzles slightly. If Jane Street are watching this,
Sorry.
sorry, I guess. I didn't promise not to alter them. I've altered them in some way. Hello, Lala in chat. And heebie-jeebies says, "Yay, puzzles." Oh, I read that one already. Good. I have added a frog because I wanted a frog.
Adorable. Who
It is
knew
a bit,
James
isn't
was
it?
an artist?
Art stream. Here's first puzzle. Beth is not allowed to solve this like straight away. We talked about this. Okay. I have to warn Beth because I think okay. This is Frog. Frog is thinking of a whole number. It's between 1 and 15 inclusive, so it might be 15. Is that frog thinking of a large number? Is that frog thinking of a small number? We can find out. You can have up to 4 guesses, and after each guess, Frog will either say yes if your number is correct, or higher or lower. It's a guessing game. You win if Frog says yes. What your guesses are going to be? How are you going to do these guesses? You can let us know in chat, I suppose.
This is quite already spring themed.
Is
Frog?
it a frog
Spring?
spring theme? Well,
Go with James.
Yes, frogs are spring themed. Do you get frogs in the spring? Is that
I don't know.
okay? Yeah, cool. Yeah, frogs are spring themed. Welcome to Spring Puzzles on the Oxford Online Maths Club.
Spring puzzles.
Here is a cute frog that I drew because I wanted to. Oh yeah, okay. Chat's on this. Oh yes, chat, go. Ah, yes. There's loads of people joining in. An anonymous person asks, "Does Oxford get a cut if somebody applies to Jane Street?" And the answer is no. Jane Street also do stuff with current students, I think, or do they? They're at the careers fair, I think, usually.
Yeah, they come around a lot.
Have they given you any free stuff?
They give me all sorts of free stuff. I have a keep cup and about 10 different t-shirts from them. They all have like little maths puzzles on them. They're really cute.
They're semi-famous for their maths t-shirts sometimes with maths puzzles on, which yes. They also do t-shirts with loads of t-shirts with camels on, and they tell me that it's because of programming, and I haven't worked out.
I think it's their own programming language.
I haven't quite worked out. I haven't got to the bottom of this camel programming language. Okay. So we got different chat. You get different guesses in chat. Let's try and read some of these out. I'm saying different guesses because, of course, you have to guess what Frog is thinking. Yes. So, Mary in chat wants to go 5, 10, 15, sort of increasing to search through the numbers. Of course, those are large gaps between 5, 10, and 15. And Matty says binary search. Rex says binary search. Wilson says binary search. Rex says start at 7. Geo says start at 8. 8 right, there's 7 because there's 7 below and 7 above.
Guys, what is a binary search? I'm not quite sure. Anyone in chat want to explain?
That is great chat engagement, Beth.
You're welcome.
Yeah, I know you know what binary search is, right? No. Oh.
I took computer science A level.
Okay. Good job. Good job. Right. Okay. Anonymous has actually got a plan that tells us how this is going to go. They haven't told us numbers. So lots of people have told us numbers, but an anonymous person says first guess reduces 15 to 7, and then 2 must 7 to 3, and then 3 to 1, and then the fourth is correct. So there's kind of like narrowing plan of how they're going to do this. Yeah, so Wilson says you gain 2 pieces of information per guess, higher or lower, corresponding to binary. I think it's slightly harder than that, right? Beth, do you want to argue against? Can you see what I'm going to say? For why it's not just 2 pieces of information?
Really.
Well, Frog also can say yes, right? There are 3 things that Frog can say, not 2.
That's true. So you could get it right on the first go. You
could just like do the total like mind read. Looking at that frog's eyes. Think of the number 8, isn't it? And then the frog just says yes. You play the game, right? You play the game. Sophie wants to start with 8 to halve the number pool, which it feels like this year. Okay, it feels like binary search is the right intuition, I think. It's kind of halving what's left. You probably shouldn't guess 15 as your starting guess, because well, it might not be. Right, okay. Yeah, so we should probably check this works, right? I think that the anonymous plan in chat was quite strong, but I'm going to just sort of check what happens. My way of doing this is kind of like a probability tree, except I don't really care about the probabilities because we have to get this for sure. So if you guess 8 as your starting number, there are 3 things that might happen. Frog might say higher, Frog might say yes, or Frog might say lower. And I'm drawing lines in those 2 cases because in those 2 cases we're going to keep guessing. We're going to keep going. So then we've got numbers over here. Just to check that I'm doing the strategy that people think I should, what numbers should I put for my next guesses in these cases?
Chat has already mentioned complex numbers. We're only 9 minutes in.
Somebody's mentioned complex numbers. Oh, right, okay.
Might be a record.
Might be a record. Chat loves complex numbers. Is that from back when you were...
Yeah, I used to watch the live stream every week, and I was one of those that were like, ooh, complex numbers.
That's a long-running meme. It's nice to know that
Long running. It's been
people
passed down through generations.
being passed down through the generations. Yes, if you're year 11 and watching this, then you have to try and force everything to be about complex numbers this year and also next year so that it continues by induction. What's the other thing chat loves? Higher dimensions. Chat loves higher dimensions.
Of course,
I don't think that was quite survived the test of time so much. There was definitely a phase where chat was really into higher dimensions. You couldn't say anything. Like you say triangle, and chat would just be like, "What about? What about? Hear me out. What about a higher dimensional triangle?"
Yeah.
Right. Yes. Oh, good. Chat has split. I like it when chat splits. Because let me get to talk about it. So is it 11 and 5 or is it 12 and 4? And how on earth am I going to think about this? No, I'm going to make Beth think about it. Can I do the lowercase first? So if Frog says lower than 8, we've got numbers 1 to 7 next. What do you want to guess next?
I think I want like an equal number of numbers around whatever number we choose.
Yeah, okay, you're going to go for, so you want to go for the middle number from 1 to 7.
Yeah.
Okay,
you
that's
don't want to
4.
go for 1.
Don't go for 1. It just doesn't feel like you're getting much information. Okay, is it 4 in the middle? I think it is 4 in the middle.
That sounds about right. 3 each side.
Because then maybe that's correct, or maybe you'll need some more guesses. And in these cases, I suppose. So down here, if it's less than 4, then you can guess 2, which will either be correct, or maybe you should guess 1 or 3, in which case you are now correct down here. And if it's higher than 4, then I guess it's now 5, 6, or 7.
Oh.
Maybe? No? Am I right? What am I doing?
No, you just said a funny phrase, James.
Oh,
no. I'm glad it was you and not me first.
Oh no.
That's going to go insane.
Chat's done really well. There was a horrible point last year where chat found a past mat question which uses as an example of how binary works. They convert a 2-digit number to binary, and once chat found out, they would just keep asking me for help with this one mat question. It's just like, yeah, I'm really stuck on this example of binary they give me. Yes, okay. Chat. I've got this like little picture of like, that's a 7 in that one, of what's going on. I feel like I could just draw this picture up here as well. And it's very, what's the phrase? Binary tree shaped. So is this is like half of the numbers left. So 9 to 15, and the halfway point is like 13, 14, 12? 12.
It is 12.
It is 12. Sorry, I'm having one of those days. Is it a 3-star day? Someone in chat missed the poll but says they're having a 4-star day. Which is,
oh, that's nice.
That is nice, isn't it? I wish they'd been in the poll. The poll came back like not the most amazing. Okay, I'm going to fill this in, and then I'm going to ask you for patterns. I love asking people about patterns so that they can spot, because I think that's. Oh, can I do this and talk at the same time? No. There we go. Okay, 7 has thrown me. Sorry, just going to do a little like.
That looks like 2 9s, James.
I know. There we go. Fixed it.
Nice.
Okay, little tree where in 4 guesses from left to right, I will at some point have guessed every possible number with some like any possible number. I've guessed it at some point in there with this plan, which I think we're calling binary search. I'm fine with that. I think it's binary search, but it might stop early if you correctly guess the right thing. Do you spot any patterns in the numbers? Anything you can see going on? Obviously, the place I'm going to with this is I would like to ask you about a version of this game with more guesses, where maybe you can determine more numbers. In this version, Frog says it's between 1 and 15 at the start. What if you were allowed more guesses? How many numbers could you distinguish? Now what I've done there is I've asked a question and then I've forgotten what the question was, and Sadler's has just said 6. I've forgotten what the question was. Beth, what? Can you remember a question that I've asked recently to which the answer is 6?
With any patterns?
Right.
Maybe there are 6 different patterns.
6 was the right number to put. Well, I mean, 6 is the right number to put here. I think I might have asked that as a question. And then, there's too much where there's a 20-second lag, and I sometimes forget about that, and also forget that I've asked the question. Oops. Yes, patterns. Highest power of 2 in the prime factorization goes down by 1 each time. Beth, help. Sky says that the highest power of 2 in the prime factorization of the numbers goes down by 1 each time.
I see that, because you're kind of halving it.
Yeah, so in binary, I guess this has got 3 zeros on the end. These have got 2 zeros on the end. And then, I learned about highlighters semi-recently. These have got 2 zeros on the end. These have got 1 zero on the end in binary, and these are all the odd numbers at the end. Matty G tells me this. All the prime numbers except 2 are in the same. All the prime numbers except 2 are odd, so they're all in this bit of the table. Yeah, Sadler says that I did do the thing where I asked a question and then moved on. It's because I've got used to filling the 20 seconds with just get Beth involved, talk to the camera, just don't say the answer for 20 seconds. And occasionally I distract myself like that and then just half or minus 2 or plus or minus half plus or minus 2 plus or minus 1. Yeah, there's relationships between them as you go down. Half plus or minus plus or minus. Yeah, if you go for the middles. Okay. So I guess the question then is, if Frog lets you have 5 guesses, what's the largest number that this game works for? I phrased that really badly, so I'm now going to use my 20 seconds to try and rephrase it. Beth, help. What do I mean? Something like...
It's like this, but instead of 4 times, you get 5 times. So what's 15 going to become? I think I did a worse job than you, James.
No, we'll have a third go. I'm kind of asking the question backwards now, which is good guessing strategy. You should probably always use something like that. If you get 5 guesses instead, you can probably just play the game with more numbers. Yes. Oh. Yeah, Sky says 31, Maddie says 31, Sadler says 31. I think chat's happy. As a formula for a relationship between n guesses, how many numbers? Anonymous, if you send us stuff that we're allowed to use, then happy to use things. I can't fit it into the live stream live. Oh, is that true? Probably can't fit it in live, but if you send us stuff for a future episode, we can include it in future episodes. Yeah, probably powers of 2. Very good. Nice. Okay. It feels like it doubles each time, right? You have 2 copies of the tree plus a bonus. If the number really is 16, half a point or something. Yeah. You could probably prove that with induction or something, or just by drawing a really convincing tree. That's valid, right? Proof by draw a really convincing tree.
That's still very spring themed, James.
Yes, convincing tree. Brilliant. Yes, spring. Good, thank you. I've forgotten about our research brief. Why are these called spring puzzles? Right, okay. New problem, new puzzle. It's a remix. Right. Same Frog, but Frog is now angry. Frog doesn't like it when you guess small numbers. When you guess small numbers and Frog has to say higher, it doesn't like that. So same game. Frog's going to say yes or higher or lower, but if Frog says higher twice in a row, you just lose the game. You have to avoid doing that. So
he's quite genius, this little Frog.
Yeah, I guess. This is really doesn't want to say higher twice in a row. You know, you've guessed a number and then frog says higher. Then you guess another number. If it's even, you've got to take the hint, right? You guess larger than that. So yeah, this is harder than the previous puzzle, and possibly we should try and find a strategy that at least works, and then try and find a better strategy. I don't know. But while I was getting this ready on the screen, incredible amount of preparation you can imagine, I'm sure. I tried to think of like, is there a kind of almost stupid strategy that just works?
Yeah, I guess you're kind of going through all the numbers strategy, but obviously you're going to have to go from 15 to 1, so he doesn't say higher twice in a row.
Yes.
So we've got an upper bound of how many guesses being 15, because
Yeah.
you could just say 15, 14, 13, all the way down to 1.
This will never annoy the frog.
No.
Yes, Anonymous has put something similar, and Lala has an improvement on that, which is that you can start at 14.
That's so true.
You can start at 14. You risk slightly irritating the frog if the number really was 15, but you can immediately remedy that by yeah. Of course, if it's not 14, you can now just sort of work your way down. Can you refine that? Can you refine that idea? Oh, actually, I should be reading chat to see if they've refined that idea already, right?
They might have.
So if you start 14, not bad. If you start 14 and frog says higher, I better guess 15. And question, you could now guess 13. You know it's, at this point, you know it's not 15 or 14 because frog said lower than 14. What can you do? What's this? So people got other strategies. Let me try and catch up with chat a little bit. Intuition is start at 12. Right, different strategy entirely. Sorry. Is it Sky earlier? Let me scroll live chat, sorry. Sorry, chat's going really fast. It's brilliant. Good stuff joining in, everyone.
A lot of ideas.
Anonymous with a thumbs up over here. Waste your guesses and double them up. No, wait, do I understand that? Double the guesses to 8. Wait, I read that out because I thought I understood it, but now I've realised I don't. What do you think double the guesses means?
Maybe it means guess the same number twice? That wouldn't make any sense.
Yeah, but then that could be bad. If frog said higher and you just repeat your guess, then it's definitely going to be higher again.
Yeah,
I got scared.
That would make you lose immediately.
I think I don't understand that strategy. I read it out thinking.
No, neither.
Yeah, so Matty and Wilson have got a strategy which is like do the binary search that we were doing before, but if frog says higher, then essentially panic and go to like, oh crikey, okay, do this like largest number downwards, which works. Has the chance of being quite bad, but maybe only. So in this world, I think you start at 8. And then if frog says higher, you go, oh crikey, and then you go 15, 14, 13, 12, 11, 10, 9. That's back.
The new suggestion in chat from Heebie-Jeebies looks quite good.
When it says higher, reset by answering 15. Oh, right, okay. So, okay, out of respect for the frog, do the same as before. Reduction to the previous strategy. I get it now. Reduction to the previous strategy. But if the frog says 15, if the frog says higher, you guess 15 just to calm down the frog. Okay, I like it. Because then the frog will be like, yeah, okay, lower than 15, fine. Okay, so that uses 7 or 8 guesses, I think. Because you might need to like take the heat off this.
I guess you can make that slightly better after you've guessed 15 once. If you go around again and he says higher, well, you don't have to guess 15 again. You can guess 14.
You could, yes. I don't know how many guesses that's going to take. Oh, this is brilliant. Lala was in there somewhere saying the thing, and also an anonymous person. Ooh, crikey. Okay. Start at 40. Decrement. Anonymous person and Lala have both said decrement by 2 each time, which is something I was hoping for, right? Like in this case, if you start with 14, not everyone is starting with 14, but if you start with 14, you started at 14 to like higher, you get 15, then you can go down. Now you know it's 13 or below, so you can say 12 safely.
Oh, I get it. That's a good strategy.
Yeah.
And that's why everyone's saying decrease by 2. I like it.
This is the thinking, I think.
James, you can't count.
I've got what?
You've put a 7 where there shouldn't be a 7.
Thank you, Beth.
You're welcome.
I go for that. For some reason, I go for the whole thing. I want to know how many guesses it takes, I think. 1, 2, 3, 4, 5, 6, 7, 8. It's not too bad, but like maybe 8 guesses. What's that work? So it's like n over 2 in worst case scenario. So roughly speaking, n over 2. Round it up. Yeah, Critica has got this halving strategy, but the frog says higher. It's 14 with lowercase, 2 down each time. So in this game, so question in chat, can you lose and then still sort of morally know the correct answer? And I guess no. Let's copy this text in as well. I'm pleased that we avoided this question before because it means I did an okay job of stating the problem. But there are weird cases in the previous one where, well, maybe nobody found this, but like there are these irritating cases where you know the answer. I think it's all of the odd numbers on the right of the tree. You know what the number has to be, but then you have to use a guess to actually get that confirmed from the frog. You've narrowed it down enough that at some point frog said smaller than 4, and at some point frog said larger than 2. So you're like,
I know what it is.
3, but you've got to use that guess, which is why the previous game took 4 guesses instead of 3. After 3 guesses, after 3 guesses you always know what the number is, but you need that 4th guess just to make the frog say yes and like get that win. Okay, what have we got? I've not been reading chat again, sorry chat.
They seem very excited about the same strategy as the first question, but with a slight modification.
Yeah. Interesting.
Can we draw that one out?
Yeah, let's draw that one. Okay, I'm going to erase this one to see if we can do one with like fewer guesses in the worst case. So what's the game plan then? Beth, you've been paying more attention to this strategy than me.
I think we start at 8 like we did.
Okay, let's map out the possibilities.
If he says higher, we've got to give 15 so he doesn't get mad.
Yeah, okay. And maybe it is 15. Or maybe it's lower.
Maybe it's not. Okay. If it's lower, it's just the same strategy as before.
Well, talk me through that, because now we've got higher than 8 and lower than 15. So I've got 9, 10, 11, 12, 13, 14.
I meant lower than 8, but yeah, let's go along one branch.
Oh, sorry. Oh, yeah, sorry, I'm going dead first.
Okay, no.
Okay, shall I come back to that one? Maybe I should come back to that one?
We'll continue. Actually, you know what, chat, I'm not very good at counting. Can you tell me what goes in the circle? Because I find it a bit difficult to count how many numbers between numbers.
Yasin says start from the middle, 7 or 8. There's a slight hedge. Sophie says stay at 8, apply the first strategy, but then you've got to do some resetting sometimes. I'm interested in how much the reset affects things. And then so the lower bit, I'll draw in the lower bit. Right, Wilson says 11 or 12.
That's not helpful, Wilson.
And we are trying to minimize the worst case, not minimize the average case. Yeah, like in the previous game, we I don't know how it changes the previous game, but in the previous game we were interested in how many guesses it takes to win the game no matter what, which is like worst case analysis. There's also this thing, I think it's in computer science A level, where you do like best case analysis. So like worst case analysis, you think about the worst, like, well, no, you have to keep guessing.
Oh,
Average
yeah.
case, and then best case analysis.
Remember that.
But we're not going to talk about best case. We're not going to talk about best case for this family of problems, because best case in these problems is always you just guess the number correctly first time. You just guess it, and the frog's like, yeah, maybe the frog is playing along to make sure things go well for you. Yeah, okay, right. Chat's now got 12 for this, or like, maybe it doesn't matter between 11 or 13. So I don't know what to write here. I'm going to try putting 12 just because that's come in recently. And then if frog says higher, so I guess the planning ahead is like, now you guess 14.
Yeah.
And then maybe you still have to guess 13 if frog said lower. Down here, what if frog says lower than 12? You now have 9, 10, 11.
Mm.
Can you do those by guessing 10, I guess? And then like 11, 9?
That looks good.
Looks good, I think. I've drawn these last two quite small, but those would be 1, 2, 3, 4, the fifth guess that you make. And then I think the rest of this is to fill in the lower part of the table, but I think that's going to be fine because we haven't annoyed the frog even slightly. I think. Sky says this strat does it in 5 every time. I'm kind of interested in what happens if you made a different choice in this cell, because we threw it to chat and chat gave us different opinions. You can sort of see that 12 is nice because it's got 3 things underneath, which we're happy with, and it's got 2 things above, which we can deal with. Down here, I guess the strategy that people are describing in chat says that I should guess 4 next, because that's what we would have done anyway. And then the cases are, maybe that's correct. Maybe it's lower again. Maybe it's higher. I haven't left much space for this. If it's higher, then I have to guess 7, I think.
Yeah. Which
might be correct. Or it might be lower. In which case, oh gosh, does it matter if I guess 6 or 7? 6 or 5? Didn't even need to do it that time. I think it doesn't.
Not sure it does, no.
I don't think it matters. There's like some chain here where you got to distinguish between 5 and 6. That feels a little bit clumsy, but
it's still within 5 though, so.
And this is not too bad down here. I think none of these involve frog saying higher twice, so we're safe now. At some point in this case, the numbers are just low, so frog is wasn't going to say higher twice anyway. You can flip these two around. You got a bit of flexibility here. Sky, how does this work? If you go from 8 to 15, then 12, and the frog says higher, do we lose? I think we don't lose. Oh, right. Did I phrase this wrong? It's twice in a row. You can kind of reset the frog's anger levels by having get frog to say lower in between. Which is not the case here in any of these paths through this network. I don't quite know what language to use. Branches through the tree?
Yeah, let's stick with the tree analogy.
I think they'd never have 2 H in a row. Good, okay, I think this strategy works. Good job, chat. Well done, everyone. And there are slightly different versions as well. Hard questions.
Is this one more guess than the last one then?
It's turned out to be just one more guess. Which makes me think follow-on questions, right? And it feels like we had a bit of flex at times, like around about the 5 and 6 part of this plan. Down here somewhere. Feels like we could have it could have had another number in there.
True.
It could be slightly better. Yeah, and the way I want to explore that is something like we did before. How hard can I make this game, right? If you have 5 guesses. Oh gosh, let's write it in here. We've seen that with 5 guesses, we've got 5 guesses. 5 guesses is good enough for 15. Can you distinguish more numbers using 5 guesses like this? Sorry to keep flipping the puzzles around. Although I think it's a good skill or a good lesson. I don't have a concrete example planned, so if you can think of a concrete example, Beth, for this effect where you're either trying to prove something or you're trying to sort of run it backwards and find out what conditions do I need for this to work? What's the
kind of like optimizing?
Yeah.
It's quite.
And a bit like generalizing as well. So sort of not resting after you've proved it. If A, then B. Well, what else? Like, can I make this stronger by changing this? So Sky's got a conjecture, right, which is a generalization. So it's always one more guess, but it might be more complex than that. It could be slightly better because you can guess a higher number than your previous. Yeah. So my way to generalize this, or to work out how many things we can do. Before we had this formula that was like 2 to the power of n minus 1. My way to this is to try and draw the tree first, and then we'll fill in the numbers afterwards.
That's a good strategy.
Right. I'm not sure it's particularly obvious that I can fill in the numbers on a tree. It does work. You have to do it quite carefully, but for example,
I feel like we're about to do a very weird Sudoku.
Right, so given a tree which looks like this, maybe you've decided that these are the only possibilities. Maybe this is a different frog with different restrictions on its behavior. Then you know which of these circles represents the smallest number. It's got to be this one down here. And if you're playing to win, then you've got to be able to guess the number 1 at some point. So you've got to fill in 1 down here. And you can go from there. There's a well ordering on the numbers. So let's see if I can sneakily get away. Should I get away with that? I think I did. It's all fine. Yes, maybe this improvement applies for bigger cases than 15. Yeah. There's some traily leafy bits in there, maybe redundant. I think I agree with that gist of things. So let's work upwards, right? So that has to be 1. If this is the tree of everything we can explore, then that has to be 1. And then the next lowest number is this one. And then the next lowest number is this one. And then this one. And then this one. I don't have computer science A level, so I don't know what I'm doing. I'm looking at Beth. But I suspect that this is like some sort of depth first.
Yes.
Sort of. What am I doing? I kind of...
That does make sense. Because you go all the way down to the lowest, and then you kind of go back up 1, and then carry on going down to the lowest.
And then go back up and sort of fill it. So yeah, okay. So it's not... Yeah, okay, I don't... I walk up if I have to, and I mark that 1, then I go down.
But you don't walk up if you don't have to.
Yeah. So this is at the moment this is just part of the original binary tree. I'm just making this observation that if I give you any sort of tree for frog behavior, then we're good. So I'm going to try and draw the biggest possible version of this tree, where we never have the frog say higher twice in a row. But I'm going to try and like maximize this tree, and then fill in the numbers afterwards. which means something like counting how many circles there are, but also filling it in and labeling. It's like dream state. We've got our initial guess, and in a perfect world, following our initial guess, the frog will either say higher or lower or correct. Kind of, because if not, we're leaving something on the table, right?
Mm-hmm.
If you start by guessing 15 or the highest possible number, whatever it is, then you're missing out all these possibilities, I think.
Yeah, you could have done better.
Could have done better, probably. So then, if the frog says lower, well, ideally we'd guess a number where the frog could say higher or lower down here as well. But if the frog says higher, then something different happens. Because the frog's not allowed to say higher again. So, let's see if I can... let's see if I can explain why. I'm just going to draw one line coming off that. I guess I should have it going slightly down, sorry. To indicate that it's a slightly lower number.
We have a guess of 19.
Cool, good guess.
Sounds promising.
Slightly larger than 15, so that's all right. I wonder if they have a method. Oh, so this is slightly different from a binary tree now, because sometimes it's not. There's only one branch coming off. In particular, every time the frog says H, I then have to just have a single branch. If it says L, I've got permission to do this. If it says H, I have to guess something where it will say lower next. So L, so I'm safe to guess some number where it will either guess higher or lower. And then for my fifth guess, in this case, I have to guess something where it'll say lower. I have to guess this one so that it will say lower, and then there's got to be only one number left so that I can guess it. In this case, I'm free to guess some number where maybe I've got 3 left, and the frog will either say higher, and then I'll finish the job, or the frog will say lower, and I'll finish the job, or maybe that was the correct number, in which case I'm done. Can't see what down here. That one, only one case, that one, 2 cases. Sorry, this is not the most interactive, fun bit of the live stream, is it? Yeah, and we could maybe have done smaller cases. The thing I like about this picture is that all of the smaller cases are here. Just read from the left. So if you have one guess, good in puzzle solving instinct as well. If you have one guess, it's not much of a game. You have to guess one, and you can only you have to hope that the game was frog is thinking of a number between 1 and 1 inclusive. You get one guess.
What could it be?
Frog will either say yes or higher or lower, and if frog says higher twice, then you lose, so careful. It's not much of a game, right? It's all mad game. You guess number 1. This version of the game is kind of the same, where you get 2 guesses, and to be honest, in this case, when you make your second guess, you don't want the frog to say higher anyway, because you've run out of guesses, and you need the frog to say yes. That's not much of a game either. This is the first interesting one, I think. If you get 3 guesses, you get access to this tree, which has got 1, 2, 3, 4, 5, 6 numbers in it instead of 7. So that's the first point where the frogs. That's the first guess where the frogs not allowed to say higher twice rule really starts to restrict you. If you get 4 guesses, I think this tree has got 11 things in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 things in it. So you can only distinguish numbers between 1 and 11 using that strategy. And with 5 guesses, it's now got 19 things in it, which means I think that we can play frogs thinking of a number between 1 and 19 inclusive. I'm going to fill that in just so that we've got like the ta-da picture. The question is, I guess the question is going to be what's going on here? What are these numbers? The sequence goes 1, 3, 6, 11, 19. For how many numbers can you distinguish? Gosh, I feel like I've remixed the puzzle now so many times. There's so many levels deep of remix that I have no idea if this makes any sense. Beth, help.
I'm just trying to work out the.
I don't do the puzzle.
Conjecture a formula, really.
So this is what you do with one.
Oh, James, you zoomed in, and now I can't see the number.
Oh, sorry. 1, 3, 6. It's not the triangle numbers. 11, 19. Okay, it's not the hexagon numbers. What on earth are those? I don't think you're going to recognize that sequence. It's not like a famous sequence.
Chat, anyone got any ideas?
I'm going to go lowest.
I'm at a loss.
6.
It might be
how to get from 1 to 6. The tree's like a fractal. It's got this little bit of tree. Tells you how to get from 1 to 6 as well. And then you have this.
Fractional dimensions.
If I tell you the fractal dimension of this, then that's all. I'm not going to. I think 11 here. So this shows you how to play the game with 1 to 11. And then if I zoom out a little bit more, you have this kind of guess on the front where maybe you guess 12, and then the very first thing you guess is in this version is 12, and then Frog says lower, so you go 7, and then you get to play on that smaller bit of tree. And then up here, I go to the deepest level. Is this depth first? Is this what? I don't know. I think I'm doing it right. 13, 14, 15, 16, 17, 18. 19 feels weird. I don't think I've done that pattern of filling in a chart anywhere else. Depth first, but you along the way I don't go straight from that 14 to the one that's marked 17. You're going to go via this one and via that one. I find that weird, but hey.
There are some good guesses in chat. We've got some
yes.
2 to the powers. We've got some Fibonacci.
The second difference, yes. People are well trained to look for differences in sequences, right?
James, you've done some maths wrong.
Have I?
Yeah.
Not my first
What's
time.
6 minus 3?
Just excited to be here, Beth. Just having a great time. 2, 3, 5, 8, which is a sequence that I've seen before.
Oh, I know that one.
Oh, okay. Fibonacci. Yeah, right. Okay. Yeah. Well, then second difference. People are well trained that maybe it's a quadratic sequence, right? Because if you do the second differences, you get. Oh gosh, tell me this is right. 1, 2, 3.
Yeah,
and at that point, it's not clear whether the next number is 4 or 5. If it's 4, then I think this is counting numbers. If it's 5, then suspicious.
Yeah.
So possibly I need to draw one more tree, even larger than this, to settle the problem of, is this a bit like the Fibonacci numbers, or is this a bit like some quadratic sequence? In particular, is this growing exponentially, or is this growing quadratically? Can't tell yet, because there's not enough data.
What does your intuition say, James?
So this is a kind of recursive thing. Each time we've got a reference to the previous problem, and those are quite Fibonacci. I've got some maths for that if you like. I'm trying to decide whether I should do the maths. Is it a chat poll? We could do a chat poll. We've got like 10 minutes. It feels like. Hang on. Yeah, okay, we're going to add a chat poll. Can I work out how to do chat? Yeah, multiple choice. Sorry, right, okay. Do the recursion maths. And the options are going to be like yes and no. If we vote no, then we'll just do like a different puzzle or something. I'll find a way to make the frog more complicated. But you can vote for maths if you want to see the maths. Why is it Fibonacci-ish? What's going on that's Fibonacci-ish? I'm going to wait for more than 3 votes. Oh, I can imagine the first 3 keenest people and then close it straight away. It's a little bit like Beth. I don't know if you've been to in-person stuff that we do. Where you do hands up for people to answer questions.
Oh yeah, I'm familiar with that format.
Familiar with the format, right? And Maths Club has helped train me not to do that.
People get
Because
too excited.
fastest finger is like different from average finger. It's like the fastest versus the average is different on optimization. In this case, fastest fingers turned out to be about the same answer as average finger, but average finger is not a thing people say, and I've said it twice and I regret it. It's gone all right. Okay, people want some recursive maths. People have voted for recursion, which means we now do another poll. The poll is the poll is the same, but we keep doing the same poll until we get the right answer. Right? Okay, no, joking aside. Did I prepare the maths for this? Yeah, this is going to be super fine. This is going to be okay. Yeah, okay. I've got the recursion, and chat said Fibonacci a lot, so I'm trying to plan ahead to say what's the point at which I say just like the Fibonacci numbers. Or I think it's not quite yet.
Someone has said the differences are just Fibonacci again, duh, which I quite enjoyed.
2, 3, 5, 8. Well, this was pointing out 2, 3, 5, 8 is just a quadratic. The differences are counting numbers, so there might be. There's a quadratic that goes through those points as well. So, right, okay. So we're gonna need some sequences. I'm afraid it's 10 to 6, and I've got to stop at 6. Beth's got to stop at 6. Chat's got to stop at 6. We've got to get out of here in 10 minutes. Let's go. So let an be. Let's try and define this. What is this? I guess it's the number of circles in one of these trees. So this is kind of the puzzle we're trying to solve. It's kind of a bit like you've got this tree, frog hasn't said anything yet. And we're going to let Bn be the number of circles in a tree where frog just said higher. So I'm using AN and BN technology here to have a kind of, the difference between A and B is how angry the frog is. I don't know if I'm making any sense. I'm sort of rushing it, right? But like AN for the number of circles, assuming the frog's just said like nothing, or the frog's like chill, maybe it just said lower, and the frog's chill. This is the effect that the number of circles over here is like a n minus 1. It's like playing the game with one fewer guess, and the frog's not cross with you. So you're safe to do like the same structure that you would have done in the previous case. This is what I mean about the recursion thing. It's like related to the previous problem. If the frog says lower, this is like a n minus 1. And over here, the thing I'm trying to track is that this is a tree. It's got fewer circles in it because we went into this one with a cross frog, and in this case, you've got n minus 1 guesses to go, and this is a sequence that I'm calling Bn, or Bn minus 1, whatever, for how many guesses you've got, how many circles there are in this bit of the tree. Yes. Okay. So the formula then is AN, the number of circles, is 1 for that circle at the start if you just nailed it first time, frog says yes, plus AN minus 1 for what happens if you guess and the frog says lower, you get to play smaller, fewer guesses, and Bn minus 1 if the frog said higher. And then also there's a recursion rule for Bn, which is the, or Beth, do you want to play along here? What's the, sorry, throwing you in midway through as well.
If you kind of zoom into
Yeah.
bn, or bn minus 1, if you ignore the 19, it looks quite similar to the original. So I'm thinking maybe it's 1 plus an minus 2.
Yeah, nice. Yeah, so in each case, you get one lucky guess if it was the highest possible number left over. You get one circle there. Otherwise, the frog's going to say lower. You have to structure your strategy so that you're guessing the highest available number. That's the circle. Then the frog might say lower, and then you're now safe to play the game over there. I have shifted slightly from what you said out loud, so it's let's just do it like this. So I'm going to write down what you said. There you go. Yep. So that'd be you have one lucky chance if it really was just the highest number available. And then a minus 2. So you can plug this into there, and you get an is 2 plus an minus 1 plus an minus 2, which is pretty Fibonacci-ish, right? It's the sum of the previous terms plus 2 each time, which means it's not just 2 more than the Fibonacci numbers. It's not just 2 more than the Fibonacci numbers, because the 2's are kind of hidden in the 2's kind of snowball if you work out how many plus 2's are there in this formula. Oh no, the an minus 1 and the an minus 2 also got plus 2's in them as well. But the rule is that you add the previous 2 plus 2. 1 plus 2 is 4, plus 2 makes 6. 3 plus 6 is 9, plus 2 makes 11. 6 plus 11 is 17, plus 2 is 19.
What a cool sequence.
It is a cool sequence. It turns out that yes, there you go. It turns out that this grows like the Fibonacci numbers, which semi-famously grow like golden ratio to the power of n. Previously, it was growing like 2 to the n, which means that if you needed 4 guesses before, then you probably need about 8 over 5 or something guesses for how many guesses you need now. Or I've tried to do the comparison ratio thing there. It's not gone very well. But you need more guesses because phi is a little bit less than 2. Neat. Fibonacci numbers. Fibonacci numbers famously associated with rabbits. Rabbits famously associated with
spring.
Okay, we got there in the end.
We've gone full circle.
We've come full circle. Well done, us. Charles is doing a great job in chat. Chat started talking about math again, although someone says, what is math? Which is the new age, it's the new world. Math was an entrance test used by Oxford Maths Admissions Test. I was in charge of it, and it ran until 2025, which was the last one. Oxford now uses TMUA for admissions. Yeah, we haven't released the multiple choice questions for a couple of years, and we're not planning to, in case we reuse them in the future. Yes, and Anonymous in chat has posted the formula for Fibonacci numbers. Or maybe it's the formula for, no, it's not the formula for Fibonacci numbers. It's the formula for my sequence.
BN. That is some work right there.
They've got to solve for A and B. They've got to apply the initial conditions by thinking about the first couple of terms. You got 2 extra data points, which will also help us work out if they're starting from n equals 0 or n equals 1. Probably they mean n is the number of guesses. Yeah, it's just like Fibonacci numbers plus triangle numbers, I think. It'll work out, right? Good, cool. Right, okay. Thank you very much to Charles moderating chat, running things over in live chat. Thank you everyone in chat for joining in with live chat. My God, like 158 facts about frogs in chat. That is 100% what chat's talking about. Comments about frogs. Look at it. I'm going to go back. I'm going to go back to Happy Frog for the wrap up. Happier days. Thank you, of course, to Beth on stream joining in with puzzles. People can send us stuff. There is an email address on the screen and in the YouTube description. Beth, anything you want to say at the end?
You can't put me on the spot here.
I've put you on
Chat,
spot.
you were great this week. Love
Good.
the interaction.
Good job, chat. Great. Yes. Okay. We'll be back in 167 hours. I'm stressed about daylight saving time, which is going to ruin my wrap-up message. I'm going to have to really think really hard. We'll be back, I'm pretty sure, in 167 hours for another episode of the Oxford Online Maths Club. Until then, have a nice evening, have a nice weekend, have a nice week. But it's bye from both of us. Bye.
Bye.